First of all, I want to wish welcome and a pleasant and nice day to today's symposium to all participants that come on a presentation of the first results in scope of our project E-Cube, or with the full name Research of the Integration System for Spatial Environment Analysis and Advanced Metal Recovery to ensure sustainable resource development. I want to introduce chairman table for today. For today, there will be Mr. Shimbo, which is project coordinator, co-chairman, and also Professor Masuda, co-chairman, and I will be today chairman of this symposium. On the beginning, I will underline some of the importance and benefits of this our project. As you know, most of you know, that total project budget is around exactly 5.6 million US dollars. This budget is divided from two parts, which is covered from the side of Japan, and this is 4.8 million, and the other which is covered from the side of Serbia. This is 0.8 million US dollars. This budget will be spent on development of new technologies and definition of processes for making some new products, keeping our environment clean, and the final object of this approach is to ensure sustainable development in our region, in eastern Serbia, and try with the starting of solving of so many environmental problems collected in previous period. Beside the definition of new technologies and beside of the production of new products, possible products which will be used in some other industry, one of the big benefits in scope of this project is the creation of a new geochemical map of considered area. This new geochemical map will be produced using field survey, which will be performed mostly from the researchers from the Serbian side, and will be used and also the other important issue for this will be satellite imaging, which will be performed by new knowledge that will be transferred from the side of Japan experts. So, by combination of these two activities, we will make a new geochemical map of considered area in Eastern Serbia. This is mainly cities Bor and Majdan. In scope of our project, also, there will be installed a most advanced equipment during project. This will be devices for the measurements, for the analyzing of samples, different kinds of samples. There will be XRF, XRD, ICP-MS, ion chromatography, spectrometer, etc. These devices will be used in scope of this activities, in scope of project, and after the finalization of the activities in scope of our project, keeping future activities and analyzing objective to keeping environment and making environment clear and better for living. Also, in scope of the project, there is provided a lot of training courses for the researchers in scope from Serbian team. In total, there is provided that there will be around 35 short training courses from different parts. There will be specialization courses for the metal recovery, for the environmental protection, and also there is provided 4 PhD also from these fields of expertise. This will bring new and young experts in our team, which will be with new knowledges and which will be some kind of new force in future works of our institute. Main partners, I want to present main partners in our project. Main partners are Akita University with different departments, also Japan Space System and company Mindeco. And I especially wish to representative of these companies today pleasant state in our institute and on this symposium. From the side of Serbia, there are main participants: Mining and Metallurgy Institute Bor and Technical Faculty in Bor. Also, all activities in Serbia are covered with the participation of two ministries: Ministry for Mining and Energy and Ministry for the Agriculture and Environmental Protection. Now is August, and I am happy to say that project activities are intensified in last period. Now we are start with real testing, real sampling and treatment of collected samples. So now is become collecting of the new of the results which will help in achieving the total object of this project. Therefore, it is my great pleasure to open this first symposium and to see some of these first results. On the beginning, I want to give few more remarks. There will be total 6 presentations today, 3 in first half of today's symposium and 3 in second half. These presentations will be consisted mostly from the results achieved in this project, but there will be also presentation with the results from our previous researching, and also there will be some presentations which will be very important for us in better understanding the situation in this eastern part of Serbia, and we hope that this will help in definition of the next steps and future activities in scope of our project. By our opinion, it is very important that today all participants understand this symposium very relaxed and be free to ask any question after presentation. This discussion, we expect that will bring to the clarification of some technical details. Also, there will be a discussion which can help us in some our consideration for some future step, for example, sampling points and the way of some activities which are in front of us. So, that's for now. I want to open this first symposium. Wish to everybody pleasant and successful work. And now I want to ask first presenter to start with his presentation, Professor Dragan Milovanovic.
Geology of Serbia includes different kinds of rocks, starting from metamorphic, magmatic, and sedimentary, starting from old Paleozoic up to now. If you work in structural geology, geotectonics, and petrology, you're lucky to see practically each kind of rocks which exist in our planet. Eastern Serbia is really inspiration for all geologists. Just one comment: we have tradition geology. More than 150 years we have our school. So many people work here, not only for Serbia, and got it interesting results, of course, with open question. This is detail of Eastern Serbia geology. For orientation, we'll give you some places, just shortly passing through old Paleozoic to Quaternary rocks which occur here. Oldest rocks in Eastern Serbia are Proterozoic metamorphic rocks. They occur here, near the Danube. It is gneiss, mica schist, And this is one outcrops. These rocks are relatively fresh, without contamination, without contain of any elements who has influence of ecology. This is picture or details of the ugnesis. Here we can recognize quartz, orthoclase, and biotite. This is all Paleozoic metamorphic rocks, metamorphosed in condition of amphibolytic facies. Next rocks are slightly metamorphosed, but also Paleozoic. Ripheocambrium green rocks, Goriane granitoid, here is Delio and Gabbro. These rocks occur here, little bit here and here. They can, or we can, relatively easily recognize because they are green color. Green color is consequence of chlorite and epidote. In these rocks, we don't have mineralization. These rocks are healthy, I would like to say, of course, from medical point of view.
The combination of ASTA and Landsat is very sustainable monitoring way because Landsat is free of charge. Every 16 days, Landsat is observing the Earth. And also, ASTA is the same orbit with Landsat. And the cost of the ASTA is not so expensive, just around $100 US for 60 kilometer, 60 kilometer. Okay. Of course, the resolution is 30 meter and 15 meter. This is not good enough for the local consideration, local study. But the more bigger area, we can use this satellite. Anyway, you can see the difference because our video camera also, this is one of remote sensing tool. Yes. Okay, digital camera also. And Google Earth, that is one of remote sensing data. The definition is the technique obtaining information about the phenomena or object from a distance without direct contact. So we can get the information of the object from the distance. This is a basic definition. And also, remote sensing uses electromagnetic radiation, which is an invisible form of energy that travels through the universe. Okay? Our eyes just can recognize very narrow range of wavelengths from 400 nanometer to 750 using the reflectance signal of the sun radiation. And the SAR, synthetic aperture radar, this is a microwave sensor. Okay? This is useful especially for the detecting the geological information in rainforest area, which is covered by the dense forest. Okay? Another type is digital elevation model. Digital elevation model is similar to topographic map, but this data has the elevation data in each grid.
We did a study from 2011 to the 2013. Okay, here. Then we did a small study on environmental evaluation. Today, I would like to explain our result. Okay, so, and then this is a title of my presentation. Then this is a table of the contents. Okay, so I'd like to start my explanation. Okay. This is a map showing location of the ore body. This is an open pit of the Bor mine, and then this is an open pit of Kimberley cleavage mine, and then this is maybe a Servo open pit. So, and then around the open pit, there are many large quantity of the mine tailings. And then this is a picture of the Bor open pit. Now we can see the greenish color in the bottom. So maybe this water contained high copper concentrations. And then this is one of the examples of the mine tailings. So, and then, in this area, there is a mine tailings, and then also there is a mine drainage water. Okay. This is one of the picture of the mine drainage water. This is the location is a Roble Lake. Maybe you know this place, and then we can see the reddish color mine drainage water, and then pH is 2.6. It's acidic water, and then you can see the brownish color precipitate. This is the iron hydroxide containing arsenic. So, and then also you can see the confluence point between Bor River and also Berike Cleavage River. And then Mr. Hirose showed this river water. This is a mine drainage water containing municipal wastewater, but pH is still dissolved on iron hydroxide. But copper tend to stay in solutions, maybe, yeah. So because in downstream of the Bor River, Bera River,
Yeah.
in downstream also copper concentration is high.
So less than 0.5%. So in the case of this low-grade copper ores, so we have to use some additional and optional process. For example, the conventional and additional hydrometallurgical process. So in the case of the primaries or chalcopyrite, such as chalcopyrite, this is one optional process, and also pressure leachings. So this chemical and bioleachings is very difficult for the chalcopyrite, as you know. This optional and additional leaching technology is depending on the minerals characteristics and also metals. So this is a comparison with ferric chloride and sulfonic acid leachings. The ferric leaching is more soft and mild conditions, such as this sulfonic acid. Lower temperature and lower pressures is better. But this advantage point is iron concentration is very high. So this is the one disadvantage point. This is a new focusing technology for the hydrometallurgical treatment. So this pressure leaching has some advantage, oxidations and very quickly leaching and dissolutions. And also some advantage point is here. And also disadvantage, high costs and oxidation supply is necessary and so on. And also disadvantage, high costs and oxidation supply is necessary and so on. So in the case of the in practical operation in the mining industry, we have some pilot scale autoclave leachings. In that case of the CESRO process is very commercialized important technology in the Canada, and also Brazil and so on. This surface passivation. So in the case of the sulfuric acid leachings, the sulfur or elemental sulfur coated the surface of the chalcopyrite. So this is the big and serious damage for the copper dissolutions. So this elemental sulfur is we must oxidate the copper solutions.
Name of my presentation is Integrated of Treatment of Flotation Tailing in Mine Wastewater, and this presentation contains previous result of copper leaching from flotation tailing in earlier period. Procedure for experimental research of integrated treatment of flotation tailing in mine wastewater. Samples from the flotation tailing dams were treated by the agitation leaching method. Laboratory experiments were conducted on samples of 100 grams. Experiments were carried at the following conditions. For experiments of leaching process with oxidant was used ferric sulfite in concentration of 7 grams per liter, ferric 3+.
First part of this presentation is sampling of characteristic wastewater in the Bor region. In order to preliminary investigation the heavy metal content in surface water flowing Bor municipality. The next places are sampled. It is Bor rubble accumulation. On a figure 2 is a Bor river, and here is presented the apparatus for measuring of the parameters on site, field site. Here is the sampling of Krivel River. Neutralization of artificial acid mine drainage was done with copper, iron and aluminium content. In table 2 is given the concentration of this element and the compound that used for preparation the solution, and compound for preparing 1 liter of solution. This compound are used because it is a sulfuric compound that is soluble in water. Sludge was dried on room temperature and filter solution were used for chemical analysis. Chemical analysis were done by ICP, OAS method and photometric method. Sludge sample will be used for further experiment to soluble in sulfuric acid solution to prepare solution for S6EV process. Test with lime milk was done with a different volume of artificial wastewater, aim to use this volume for chemical analysis and for further experiment.
We have to take and to consider all effects and all facts when we make some environmental estimation about what is from the industry and what is not from the industry. So I believe that this is second very big thing that we today heard, that there is a lot of data which can be used in future steps and definition of the sampling and interpretation of the sampling results. And finally, I believe that the most important thing during today's symposium is mixture between Japanese and Serbian researchers, to know each other and to introduce each other and to know what researcher from Serbian part and what researcher from Japanese part working, and to know much better who is, what is which discipline, and to make a better connection for better work. This is our first symposium, and I believe that it is completely successful. So thank you to all of us, and I wish a very nice cooperation in future time and a successful project. Thank you very much.